optimization video part 3. Let's do this problem. We have given a rectangular sheet 8 centimeter by 6 centimeter. Rectangular sheet 8 centimeter by 6 centimeter. Let's say this is it. So 8 centimeter is the length and 6 centimeter is its width. Equal squares of side x centimeter are removed from each corner. Same as we did before, right? We remove from each corner equal squares of side x. Also here, also here. And when we fold what the rest of the cardboard, we will have a volume, right? We will have a box has a volume. Okay, that's great. And the edges are then turned up to make an open box of volume V centimeter cube. Part A, we are told to find the volume in terms of x. What is the volume of the box? Volume of the box is length times width times height of the box, right? So what is the volume of the box? Volume of the box is height. Height, when we fold this, x will be equal to the height. This is the height, right? Times. What is the length of the box? If the length was 8 centimeter, this means its new length is 8 minus twice x, because I removed x from each corner. And what is the width of the this? It was 6 centimeter, right? But we removed also twice x, because x from each corner, what left is 6 minus 2x. This means it's x into 48 minus 16x minus 12x plus 4x squared. This means equal to 48x, right? Let's start from here. 4x squared times x, it's 4x to the power 3. We can add those two. Negative 28x times x, negative 28x squared plus 48 times x, 48x. This is the volume in terms x. Okay, this is 4x squared minus 28x squared plus 48x. That's good. let's take a domain here. Can we take a domain? Where is x belongs to what? To which intervals? To which interval? Okay, x should be positive for sure, and maximum value can positive x for sure. X cannot be negative, and the maximum value it can take, it's half of the width, right? So 3 centimeter. So this is 0, 3 is the domain of the x. X should be a value between 0 and 3 only. Why not half of the length? Because it will be 4, and that will make the more than half of the width, and this is not possible, because if x is 4, what left for the other side is 2, and we cannot take 4 from a corner and 2 from a corner, right? So this is part A. Part B, we need to have the maximum possible volume and the corresponding for the value of x. Maximum possible volume. To have that, we find directly the derivative, because we are maximizing here, right? So it's 12x squared minus 56x plus 48. This is the derivative of the volume. Taking this derivative 0, we find by delta, or let us first, we can simplify this, right? By dividing by 4, this will be 3x squared minus this will be 14x, and this will be 12, right? Equal to 0. Okay, now we work with delta to have the two roots. One of the roots will be x1, let's say, will be, you can find delta, and delta will be radical 13, so it will be minus radical 13, 7 minus radical 13 over 2a, 7 minus radical 13 over 2a, it's not 7, it's negative 14. Okay, the final answer after simplifying, when you have them, this will be over 3, and x2 will be 7 plus radical 13 over 3. Those are the two values. If we find them by calculator, this will give me a value of minus 1.1 1.131, and the other will give me plus 1.131. Now, we have to admit a root in the interval 0.03. You remember we found can x be negative? No, because x is a value. We are taking it from the corner. So this one is not accepted value. This is a rejected value. So the only accepted value will be x2, which is 1 plus 1.131. And this value makes the maximum. This value makes the maximum volume box of the box, right? X equal 1.13. If we substitute this number in the volume, it will give me a maximum volume, approximation of a maximum volume, which is 24.258 centimeter cube. Let's do another problem. Mary is in a boat. This is very good problem. Mary is in a boat. Let's say this is Mary here. It's in a boat, and it is 3 miles from the nearest point A on the straight shoreline, right? Nearest point, this means this is A, right? This is A. Okay, that's good. That's good. Why this is nearest? Because perpendicular. Down the shore, 5 miles from A is her home. So this is 3 miles. This is 3 miles, and we have 5 miles away her home from A. This is home, and this is 5 miles. That's great. If Mary can run 6 miles per hour, she can run for 6. She can row her boat 6 miles per hour. And what else? And run 10 miles per hour. Run 10 miles per hour. Where should she land her boat to arrive home in the least amount of time? Least amount of time, minimum value, right? This is a minimum value. Where she has to land her boat. Maybe she has to go straight to the shore, or she has to go like oblique like that, right? Or she might go directly from B to her home, right? But I need the nearest time. That's good. So let us consider this is x. We have this is 3, this is x. This is all 5 miles. So what left here is 5 minus x. That's nice. How to find this value? How we find the value of B to this point here, let's say C. How to find the value of BC? BC square is equal to 3 square, which is 9 plus x square. This means that BC is equal to radical 9 plus x square. That's good. If she wants to row her boat from B to C, this means she has to go distance radical 9 plus x square miles. But she can row her boat in 6 miles per hour. That's right. 6 miles per hour. What does that mean? This means the total distance she has to travel from BC to CH, from B boat to C to the shore, and then run from C to her home, is the total amount Tx is equal to radical 9 plus x square, and we divide by the rate that she can row her boat, right? This is the distance, and this is the rate that she can run her boat 6 miles per hour. Plus, she still has to run a distance of 5 minus x, and this will be over 10 miles, right? Over 10 miles. So this is the equation we need to solve to have our work done. That's good. So what we have to do here, let me simplify this equation, or let us directly derive this equation. T prime of x, we find its derivative. It will be 1 over 6 times the derivative of radical 9 plus x square, which is derivative of 9 plus x square, over 2 times radical 9 plus x square, plus 5. What is 5 minus x over 10? This is 5 over 10 has a derivative 0 and minus x over 10. So it is a derivative of x, right? It's derivative of x. It's derivative of minus 1 over 10 only. It's derivative of minus x over 10. It's minus 1 over 10. This is the derivative. Taking this derivative equals 0 gives me like 2 cancel. x over